In today's lesson, we are going to be looking at the factored form. So in our previous lesson, we looked at the different forms of quadratic equations. We looked at some key features of the quadratic function itself and when we graphed it and the parabola. Today we're going to take a look more in depth at the factored form, what it gives us, and how we can use it. So in our factored form, again, a review from yesterday, again, y equals a, x minus r times x minus s. I know in the previous one we had x plus r times x plus s. Same idea, r can be any value, positive or negative. The key thing though is when we look at the r values, it's the opposite of the numbers that we see. And again, those are going to be the zeros. So in our example here, opposite of negative r and negative s is positive r and positive s. So that means our two x-intercepts are going to be r and s, both positive. Again, the a value, we talked about the a value controlling the direction of the opening, as well as the step pattern, which we talked about again in the previous lesson. So using that idea, let's just kind of go through and complete the table for each of our parabolas, or each of our quadratic functions. So if I look at the first one, I want to know what are the zeros, the direction of the opening, and the step pattern. We don't really need this here. So if we look at the first one, our zeros, again, the opposite of the values we see in our equation. So the opposite of negative 3 would be positive 3, and the opposite of positive 5 would be negative 5. So the two zeros for the first equation are 3 and negative 5. The direction of the opening, we look at that a value out front. Actually, let me keep this color-coded. So we had those two. Look at the direction of the opening. This 3 value, so this is opening up. And then the step pattern, 1a, 3a, 5a. So again, using that a value, 1 times 3 for the first value, 3 times 3 for the second value, and 5 times 3 for the third value. So in this case, our step pattern would be 3, 9, 15. And again, those values are there to help us plot the other points of our quadratic. Looking at the next one, y equals negative x plus 2 times x plus 6. Again, we're looking at the two values or the two numbers inside the brackets, and we're taking the opposite of them. So negative 2 and negative 6. For the direction of the opening, we look at that a value. In this case, it's negative, so that means we're opening down. And for our step pattern, we go back to that a value. So it'd be 1 times negative 1, invisible 1, that's there, 3 times negative 1, and 5 times negative 1. So then this leaves me with my step pattern of negative 1, negative 3, negative 5. So that would be my step pattern. For the last example, again, for the zeros, looking at those two values, opposite of negative 2 is positive 2, and opposite of positive 8 is negative 8. So my two zeros are 2 and negative 8. Direction of the opening, again, we look at the value in front. Here we don't see a value, so in this case we can assume that it's an invisible 1. So that means my a value is 1. It's positive, which means it opens up. Then for my step pattern, 1 times 1, 3 times 1, 5 times 1, or 1, 3, 5. So when we have an a value that's 1, it's not really changing the actual steps. If we had a negative 1, it just changes the signs. And then obviously if we have any other value, it would change that entirely. So again, that's just picking out the key information from our table of the factored form. Now we're going to look at each individual piece, and we're going to look at how we can gain more information from looking at these specific parts. So we're going to look at zeros. So first, what is a zero? We did mention it previously, and a zero is where the function equals 0, or where it crosses the x-axis. So these are also known as x-intercepts. And we also learned a new word yesterday referring to them as roots. So essentially, if we're looking at the factored form, when we have to multiply items together and it has to equal 0, then one or both of those items has to be 0. So for example, if a times b equals 0, then that means that either a equals 0, b equals 0, or both a and b equals 0. So that idea is what we can use to help find our zeros in the factored form. So if I look at my first function, f of x is equal to x minus 5 times x plus 4. If I want to find the zeros, that's the same thing as saying that the function is equal to 0. So the function is equal, so 0 equals x minus 5 times x plus 4. Because this is essentially one thing multiplied by something else, or one item multiplied by another item, if either of those two brackets equals 0, then this would complete the function. So this is where we find our zeros, or our x-intercepts. So we learned, or we just kind of talked about, if I have this form, I just take the opposite of the values. We're going to basically show why that is. So if either of these two brackets has to equal 0, x minus 5 equals 0, x plus 4 equals 0. Essentially, we're solving an equation. We move the value to the other side. So this gets moved, So this gets moved to the other side, becomes the opposite, so we get x is equal to positive 5. Same thing applies to the plus 4. Move it to the other side, it becomes the opposite, or x equals minus 4. So those are our two zeros. Which we can see are the opposite of the values that we have in the brackets. So in these types of situations, we could go through and actually calculate what the zeros are, or we can just look at the opposite signs, or the opposite values. In this example, f of x is equal to 2x plus 5 and 2x minus 3. This one's a little different. If we say our function is equal to 0, that will equal 2x plus 5 times 2x minus 3. So essentially we're saying that this bracket, or item, and either this bracket, one or both of them, has to work out to 0. Well, what x value gives us that? In this case, we set it equal to 0. 2x plus 5 equals 0. 2x minus 3 equals 0. And let's go through and solve. Move this term over. We get 2x is equal to negative 5. Divide both sides by 2. We get x is equal to negative 2.5. And we do the same thing for the second bracket. Move the minus 3 over. 2x equals plus 3, or positive 3. I don't need to show that plus. I can just write 3. Divide both sides by 2. X equals 1.5. So in this case, my two zeros are negative 2.5 and 1.5. So depending on how our factored form looks like, we should be able to find the zeros of that form with this understanding. In some cases, it may be very easy, like we just saw. Just take the opposite of the values. If it's not as easy, then we may have to actually solve an equation. Another key feature of quadratics that we looked at in the previous lesson was the axis of symmetry. And the axis of symmetry was a center line down which the parabola can be folded symmetrically, or basically it divides it in half. Right, it divides our parabola in half. So if we know the zeros, how can we find the axis of symmetry? Right, if the zeros are on two opposite ends of our parabola, how can we find the axis of symmetry? Well, in this case, we can add them together, or we add our two zeros. Actually, we'll say we add our zeros, and then divide by 2. If you're not sure why I'm saying this, let's take a look at the actual graph. So if I look at this function, same one we looked at, you can see that my 2 points, or my two x-intercepts, positive 5 and negative 4, those are on either ends of our parabola. And we talked about our parabola being symmetrical. You can think back to the step pattern, same thing happens on both sides. So directly in the middle between those 2 points should be my axis of symmetry. Right? If these are on either side, the axis of symmetry is in the middle. Let's just kind of go over in green here. Then that must mean that my axis of symmetry is directly in the middle. Right? So I can take my two x-intercepts, 5 plus negative 4, add them together, and divide by 2 to find the middle value. So 5 plus negative 4 is 1, divided by 2, we get 0.5. So that means that my axis of symmetry is x equals 0.5. Again, in this case, the x value represents the equation. So the equation x equals 0.5 that we see here, that's the equation of a vertical line. Previously, when we were solving for x, we were trying to find our x-intercepts. In this case, we're finding the vertical line. So let's try it with the second one. We have our two x-intercepts. We have negative 2.5 and we have 1.5. Let's try to find our middle value, right? What is this imaginary vertical line that goes between them? Well, negative 2.5 plus 1.5, we're going to add them together and divide by 2. So if we add those together, I believe we get 0.5. We get negative 1 divided by 2, which equals negative 0.5. So that means that our midline, or our axis of symmetry, that goes right through our parabola, has the equation x equals negative 0.5. And we can see from our graph, we can see that that line does exist, and it is our midline, or our axis of symmetry. So the equation for axis of symmetry is halfway between our two zeros. In this case, x equals negative 0.5 is the equation for that vertical line. Another value or characteristic of our quadratic that we talked about was the maximum or the minimum. So what is the maximum or minimum? Well, it's the highest or lowest value of the function. It's also the value of the function at the axis of symmetry. And again, we talked about the value of the function is basically saying the y value. Right? It's just a fancy way of saying the y value. So, if we know what the axis of symmetry is, we know where that middle value is, how can we find the maximum or minimum? Well, if we take a look back at this graph here, we can see that we're going to have a maximum down here at this value. So that will be where not a maximum, a minimum, a lowest value. So we know our lowest value is going to be down there. how can I figure out what that value is? What is this value, or y value, all the way down here on our function? Well, I have an equation. I know where the what the x value is going to be. So if I have my axis of symmetry, I can find the maximum or minimum by plugging in. So plug in the axis of symmetry, the AOS, or we can just say the x value, into the equation. And solve for y. So the axis of symmetry, that x value that we found, we're going to take it and plug it into our equation and solve for y. So for the first one, our axis of symmetry, I actually forget it, so let's scroll back up. Our axis of symmetry is 0.5. So 0.5. So I'm going to take that value and plug it into our equation, or we're going to try to find the value at the function when x is 0.5. So 0.5 minus 5 times 0.5 plus 4. We get negative 4.5 times positive 4.5. And in this case, we get negative 20.25. So therefore, the optimal, so we can say optimal instead, optimal value is negative 20.25. Now I can say optimal if I'm referring to either the maximum or minimum. I'm using optimal because how do I know if it's the maximum or minimum? Well, if we take a look at our graph, we essentially found a value, or the y value, down here at this point. How do I know if that's the maximum or minimum? Well, looking at this graph, I can clearly see it's the minimum. Why? Why is this the minimum? Well, the graph opens up, so that means it's going to continue forever upwards, and I will have a minimum value at the bottom. So if our graph opens up, so our graph opens up. So if it opens up, then that means we have a minimum value. So I can say the optimal value, or the minimum value, is negative 20.25. If it opened down, then we would say that it's the maximum, because that would be the highest possible value. So we found the maximum or minimum for that quadratic. Let's find it for this one. Again, this axis of symmetry, in this case, again, I kind of forget, so let's scroll back up, negative 0.5. So same idea, just on the other side of the y-axis as our last one. But same thing applies. We're going to take this value and we're going to plug it into our function. So we're going to try to find the value of the function when x is negative 0.5, or we're going to try to find f at negative 0.5. So in this case, 2 times negative 0.5 plus 5. So a little bit more of a step involved here. Multiplied by 2 times negative 0.5 minus 3. So all we're going to do is go through and solve. So 2 times negative 0.5 is 1, plus 5 is 4, or sorry, negative 1, and we get 4. And then 2 times negative 0.5 again is negative 1, minus 3 is negative 4. So we get 4 times negative 4, which is negative 16. So therefore, Again, I can say the optimal value is negative 16. And again, because our graph for this one's opens up, I would say that it's the minimum value. So we have the minimum value of our function, or quadratic, which is negative 16. So we've looked at, given a factored form, we can find our zeros, we can find our axis of symmetry, we can find our minimum or maximum value. We can also find the vertex. Because what is the vertex? Well, the vertex is just the lowest or highest ordered pair of the function. So it's that point at that lowest value or at that highest value. Essentially, it's just a combination of your axis of symmetry value and your max or min value. So once we know the axis of symmetry and the max or min, we know the vertex. So we already have those two values, right? Again, if the vertex is a point and the coordinates are the axis of symmetry and the max or min, in our case here, the axis of symmetry for the first one was, I believe, 0.5, and our max or minimum value, if we scroll back, was negative 20.25. So put those two pieces together for a coordinate, that's our vertex. For the second one, again, same idea. If our vertex is just a combination of the axis of symmetry and our max or min value, in this case the axis of symmetry was negative 0.5 and our max or min was negative 16. So we put those two pieces together, we have our coordinate for the vertex. So from our factored form, we've been able to find almost all of the key characteristics of our parabola or of our quadratic. We found the axis of symmetry, we found the zeros, we found the max or min value, and we also found the vertex. So that's why I mentioned previously that the factored form does give us the most amount of information, even though it may not appear like that at the beginning. So lastly, what we're going to do, we're going to take all of what we just learned, put it together into graphing a factored form. So the zeros for our equation for this new one, y equals negative x plus 2 times x plus 4. This one's relatively straightforward. It's the opposite of these two values. So we have negative 2 and negative 4. Let's plot those 2 points on our graph. So negative 2, negative 4. So we have our two x-intercepts. We want to find the axis of symmetry, or that vertical line, by adding the two zeros together and dividing by 2. So negative 2 plus negative 4 divided by 2, we get negative 3 divided, or sorry, not negative 3, jumping ahead. Negative 6 divided by 2, which is equal to negative 3. So that means I have an imaginary vertical line going down, going down my graph there. This is at x equals negative 3. I have my axis of symmetry there. I then want to take that axis of symmetry, substitute into the equation for x, and find the y value. I kind of cut off here. We want to find that y value. So y equals negative, instead of x, we have negative 3 plus 2 times negative 3 plus 4. Y equals negative 3 plus 2, which is negative 1 times positive 1. So negative times negative 1, or sorry, negative 1 times negative 1 is positive 1. times positive 1 is 1. So that means I have a minimum value, or a maximum value, sorry, at 1, or right here, which is also my vertex, negative 3, 1. I know that's my maximum because my equation opens down. It has that negative a value. So I know my graph is going to look something like this. It opens down. We can see that from here because it does have to go through these 2 points. We could use our step pattern to graph the rest of the points if we wanted to. Right? Just as an aside, our step pattern is 1a, 3a, 5a. We have a negative a or negative 1a, so we get negative 1, negative 3, negative 5. So that means I go over 1, down 1. I do have a point there. Go over 1 again, down 3. I have a new point. Go over 1 again and go down 5. 1, 2, 3, 4, 5. I have another point. And if I wanted to, I could keep on continuing, but I'm not going to have enough room. So this is enough to draw my graph. And I can just repeat that same procedure on the other side, or just fill in the missing side, because it is going to be symmetrical. And there we have our quadratic. So with the factored form, we should be able to find a lot of the key features of our parabola. The zeros are a big one. Then using some calculations, we should be able to find the axis of symmetry. Plugging that value into the equation and solving, we should be able to find the maximum or minimum. Then we can also take those two values, determine what the vertex is, and then hopefully we should be able to draw our graph of the quadratic. We may need to use the step pattern to find more values. If not, we should at least be able to sketch it based off of the vertex and the x-intercepts and that axis of symmetry. So again, the main thing is this lesson was a focus on the factored form, understanding what information we can get from the factored form, and also what information we may be able to calculate from the factored form.